Hello, welcome to Chapter 4, where today we're going to learn about atomic structure. If my voice is a little hoarse, I was yelling at the cross-country meet tonight. So let's start with 4.1, defining the atom. This starts off with, how do you study something that you cannot see? Well, similar to if your parents are smart and sneaky and they gift wrap your present beforehand, you can't see the present inside the box. You can shake it. You can kind of feel to see what shape it takes to guess what you got for Christmas. Same thing with atoms. We have to guess what we cannot see. So matter, hopefully you remember this from the very first section, we define it as anything that has mass and takes up space. And all matter is actually composed of particles called atoms. If we wanted to define an atom, it is the smallest particle of an element that is able to retain its identity in chemical reactions. So what I mean by retain its identity is both its physical / chemical properties. Because once you break those down into subatomic particles, they lose those properties that they have. So the concept of the atom actually intrigued a number of early scholars, and although early philosophers and scientists could not observe them directly, they were still able to propose ideas of the structure of atoms and the idea that they even existed at all. So the first scientist we're going to talk about and that you're going to see upcoming on your test is Democritus. And so this is Democritus' atomic philosophy. He was a Greek philosopher, and he was actually among the first to suggest that atoms even existed, that they were out there. And what he did is he reasoned that atoms were indivisible. So he said that they could not be divided. And he said they were indestructible, so you couldn't destroy them. That idea, we're going to learn, is partially correct. So although Democritus' idea agreed with later scientific theory, it didn't explain why we saw certain chemical behavior. So why did, for example, hydrogen, why was it super flammable? Why did certain elements come together to make a compound? The one thing that he did not have was he didn't have any type of experimental support to back what he was saying. So along came several years, hundreds of years later, somebody named John Dalton. He was an English chemist and school teacher, and he wanted to build upon the idea of the atoms, and he came up with Dalton's atomic theory. His was different than Democritus because he actually used experimental evidence to prove what he was saying. So by using experimental methods, Dalton actually built upon Democritus' idea of the atom into a scientific theory. So Dalton, what he did in order to form his atomic theories was he studied the ratios in which elements combine. So remember, ratios are like fractions, division. So how much mass of one element, how much mass of another element, and what was the mass of the compound? So his atomic theory that he came up with had 4 parts. The first part said all elements are composed of tiny, indivisible particles called atoms. So he said you couldn't divide them. We're going to learn later that this actually part of his theory was proved incorrect. The second part of his theory, he said atoms of the same element are identical, and the atoms of one element are different from those of another element. Here, his atomic theory, we're going to learn, was partially correct. Yes, atoms of one element are different from those. However, atoms of the same element are not always identical. The third part of his theory, it says atoms of different elements can physically mix together, or they can chemically combine, and when they do so in simple whole number ratios. We're going to find out, yes, that is true. And the last part of his theory, he said during chemical reactions, atoms can be separated, they can be joined together, we can rearrange them. However, atoms can never be changed into something else. So A hydrogen atom can never be changed to a gold atom. So what you start with is what you end with. So here's a good concept question to kind of see if you're grasping. How was John Dalton able to study atoms even though he couldn't observe them directly? And what evidence did he use to formulate his atomic theory? Well, what he did was he studied the ratios in which elements combine, because he could see different compounds. He could see baking soda and he could see vinegar. And what he did was he observed that when they mixed, they maintain their own identity unless they combined through a chemical reaction. So how was Democritus' idea of the atom different than Dalton's? Well, Democritus couldn't explain any kind of chemical behavior, and he didn't have any experimental support. While Dalton, he did have experimental support, and yes, he could explain chemical behavior. So in other words, what Democritus couldn't explain, Dalton could. So over here we have some liquid mercury, and it's gonna illustrate Dalton's concept of the atom. Here, every drop, no matter if it's a big drop or a small drop, it's gonna have the same properties. Mercury is a liquid. If you ingest it, it's actually, you can get mercury poisoning from it. It's considered a poison. And even if you can make the drop the size of one single atom, which means you wouldn't be able to see it, it's still going to have those same properties. It's still going to be a liquid. It's still going to have certain chemical properties of who it can bond with. Same thing with a copper coin. If you were to grind a copper coin into a fine dust, each speck in the small, tiny, shiny pile are going to still have that same properties of copper. It's going to be a good conductor of heat electricity. And even if you were to continue making it smaller and smaller and smaller, where it could no longer be divided, it's still going to have those properties, because every single atom of an element are going to have certain properties. The other concept that we're going to talk about in section 4.1 is atoms are extremely tiny. In fact, if you were looking at a copper coin the size of a penny, it contains 2.4 times 10 to the 22 atoms. So remember, that is going to be 24 followed by 21 zeros. That's how many atoms fit in that one little coin. If we were actually going to make a comparison to help you kind of illustrate this into your head, Earth's population is only about 7 times 10 to the 9th. So here you had the 9th power, and we're at the 22nd. So it is well over doubled Earth's population, tripled even. Here's another thing. If you line up 100 million copper atoms side by side, 100 million, it would only be 1 centimeter long. Whew. So what instruments are actually used to observe individual atoms, because we can't really see them? Well, despite their small size, and thankfully due to technology, we can actually observe atoms now today with something known as scanning electron microscopes. And in a scanning electron microscope, what happens is they take beams of electrons, and we're going to learn what electrons are coming up in future sections, but I know you've hit on it in junior high. Remember, these are negatively charged particles. They took them and shot them through a sample, and what happens is these electrons bounce in different areas and produce an image. So electron microscopes are capable of seeing a lot higher magnifications, so tiny that we can kind of visualize atoms. Now, with the help of electron microscopes, individual atoms can even be moved around and we can manipulate them. And this allows us to have a very promising future in both science and technology. It's going to allow us to create atomic-sized electronic devices, and we can work on things like circuits and computer chips and make them even better. The last couple of slides touch on an example of this and using this type of technology is nanocar. This atomic scale or nanoscale technology can actually become very essential in future applications or within medicine, within communicating such as cell phones, even solar energy, and when we go up to space to visit different planets. Okay, and that's the end of section 4.1. So if you have any questions, please let me know, and I hope you have a good day.